This pulley problem asks us to determine the speed of block B, which is right here, after 2 seconds, and we are given that this block starts from rest. So starting from rest means our initial velocity is equal to 0. This 2 seconds means our time is going to be equal to 2. The speed, we're looking for a final velocity, and because of this system, we know we can figure out an acceleration. This system is going to have an acceleration, and we need to figure that out. But all these unknowns lends itself to use this equation. A final velocity is equal to an initial velocity plus acceleration times time. And we know this initial velocity is 0, and we need to figure out what this acceleration is. So we can figure this out in a pulley system by first dimensioning this pulley from a fixed point, and the fixed point we'll choose is this pulley right here, and we want to dimension it to every part of the length that will change length with respect to time. So this, we can dimension this as S sub A, and we can dimension to here as S sub B. And an important thing to notice is our positive direction. We're dimensioning from this datum line down, so our positive direction is going to be down. Now, if we write our equations for this pulley system, we have a length of SA, another length of SA, and a length of SB. So we have 2SA plus SB is equal to some length. And if we differentiate with respect to time, we get 2 times the velocity of A plus the velocity of B is equal to 0. And this 0 comes from the fact that we're differentiating a constant. And if we differentiate with respect to time again, we get 2 times the acceleration of A, 2 times the acceleration of A plus the acceleration of B is equal to 0. So this equation right here becomes an important equation because it relates the acceleration of block A to the acceleration of block B. So now we go through and we look at this block, and we want to draw a free body diagram of each of our blocks. And if we look at block A, so this will be block A, we have let's move this over, we have a block right here. We know that it has a force going down, and this force that goes down is going to be this 100 times gravity. And we're going to say gravity is equal to, this is in SI units, so 9.81 meters per second squared. So this force going down is 100 G, and we're going to have a force going up. And this force going up will be equal to some tension A. And we have to figure out what this tension A is. But if we draw our kinetic diagram, so these are both blocks A. Our kinetic diagram, we're going to assume it has a mass of 100. So this mass is going to have an acceleration in the y direction, and we're going to assume a positive acceleration, so it goes down. Now, what is this T sub A? Well, if we draw a free body diagram of this pulley right here, we notice that it has this TA that points down. So here's its TA, and let's call the tension of this first chord just T. And one of the assumptions we make with these pulleys are that they are massless. So if we sum our forces in the y direction, the sum of the forces in the y direction is equal to a mass times an acceleration. And yes, it's true that this pulley is going to be accelerating up or down. This mass of the pulley is going to be 0. So the sum of the forces in the y direction are going to be equal to 0. And if we do sum our forces, positive down, we have TA minus 2t is equal to 0. So TA is equal to 2t. And you may have been able to figure this out just analytically looking at this this pulley system, but this is why that TA is equal to 2t. Okay, so we have a block A, and now let's do a free body diagram for block B. And again, we have our block of B. It has a force going down. The force going down is going to be 20 times gravity. And it has a force going up. And this force going up is just this chord right here. It's the same chord, so it is going to just have a force going up of some tension, because we define that tension to be T. It has the same tension. So this is block B, and if we look at the other side of this equation, we are going to say it has a mass of 20. So it has a mass of 20, and again we are going to assume an acceleration in this should be the acceleration of B, so we're going to assume an acceleration in the positive direction. And right up here, this is not an acceleration of Y, this is our acceleration of A, because it's the acceleration of block A, like this is the acceleration of block B. So now, if we sum our forces, we're going to get two equations. So the sum of the forces in this y direction is equal to a mass times the acceleration in the y direction. And this is true for both of these equations, and the sum of the forces here is 100 g minus 2t is equal to 100 times the acceleration of A. And for this equation, change my color, we have 20 g minus t is equal to 20 AB. So what we can do, we can come up with we can use this first equation that relates the acceleration of A to the acceleration of B with these two equations. We'll call this 2 and 3, and we can figure out what our acceleration of B is going to be. And if we rearrange this equation, we have the acceleration of B is equal to minus 2 times the acceleration of A. And the acceleration of A is equal to the acceleration of B divided the negative acceleration of B divided by 2. And we can solve this equation for T. So we have T is equal to 20 g minus 20 times the acceleration of B, and we can plug this equation 3 into equation 2. When we do that, we get 100 g minus 2 times this new expression for t, so 20 g minus 20 AB is equal to 100, and we know that the acceleration of A has this alternate expression that has the acceleration of B, so we have minus AB over 2. And cleaning this up just a little bit, we have 100 g minus 40g plus 40ab is equal to negative 50ab. And if we solve this equation, we can get an expression for AB. So we get AB is equal to negative 6.54 meters per second squared. And what does this actually mean? Well, we've defined our positive direction down, so our negative acceleration means that it's an acceleration in the opposite direction or an acceleration up. So the acceleration of B is 6.54 meters per second squared in the upward direction. And this is all we really need to figure out a final velocity. So by using this equation, we have a final velocity is equal to this acceleration, so a minus 6.54 times 2, because this is the 2 seconds, so the speed after 2 seconds. And this final velocity is equal to minus 13.1 meters per second. And again, this means this negative sign means it is going in our opposite direction, so it's moving up. So it's really going 13.1 meters per second in the upward direction.